Why, hello there! Now we're going to see 4 examples of the quotient rule. So in this example, we want to take the derivative with respect to x of e to the x minus 4 all over 2x. We're going to use the quotient rule. So this is equal to, well, we have this fraction bar, and we're going to have 4x squared in the denominator, and then we're going to have 2x times the derivative of the numerator, that's going to be e to the x, minus the derivative of the denominator, which is 2, times e to the x minus 4, times the old numerator, and we are done. Well, that didn't seem so bad. Let's see another example. So now we want to take the derivative with respect to x of 1 over the quantity 1 plus x squared. Let's use the quotient rule. So this is going to be, let's see, 1 plus x squared all squared. And now this denominator is going to be written in the numerator. So 1 plus x squared times the, oh geez, the derivative of the numerator is 0 minus, let's see, the numerator times the derivative of the denominator, and the derivative of the denominator is 2x. Done. Now we're going to see kind of a strange example. So this example is a little different than the ones we've been seeing. If you're thinking about it, you'll see that x cubed divided by x squared, well, that's just x, and the derivative of x is 1. But what we're going to do is we're going to use the quotient rule and show that you get the same answer out. So that's kind of cool. So let's go ahead and use the quotient rule here. So when we use the quotient rule, we have to square the denominator. So we're going to get x to the 4th. And now we take the denominator, x squared times the derivative of the numerator, and we're going to get 3x squared. And now we subtract, let's see, the numerator, x cubed, times the derivative of the denominator, and that's 2x. Now this doesn't look very much like 1 to me, but we can use some algebra, we can simplify it. So let's see what happens. We're going to say this is equal to, well, 3x to the 4th minus 2x to the 4th all over x to the 4th, and this is equal to, what's 3 minus 2? Well, it's 1, so it's going to be x to the 4th over x to the 4th, and as long as x is not equal to 0, we can cancel these. Well, let's think about our original function, and in our original function, x can't be 0, so this is equal to 1, assuming x is not equal to 0. Now we're ready for our final example. So now we want to take the derivative with respect to x of 2 minus x minus the square root of x all over x plus 2. The first thing I'm going to do here is I'm going to rewrite this slightly just to make my life a little bit easier. And I'm going to say that we want to take the derivative with respect to x of x plus 2, 2 minus x to the 1/2. This is going to make taking the derivative of the numerator a lot easier for poor Dr. Snap here. Okay, so now let's take the derivative. This is equal to, well, we square the denominator, so that's going to be x plus 2 squared, and now we have the denominator, x plus 2 times the derivative of the numerator. Oh, and this is pretty easy. The derivative of 2 is 0, the derivative of minus x is minus 1, the derivative of minus x to the 1/2 is going to be minus 1/2 times x to the negative 1/2. Okay, minus, and now we have the numerator, 2 minus x to the 1/2, that's a 1/2 there, times the derivative of the denominator, and that's just 1. I'm done already. There we go. Now our 4 examples of the quotient rule are done. Fantastic! Let's do some more math.